This example provides a background on the ideal gas model and illustrates its use. A number of scientists between the 1600s and 1800s observed gases in a piston cylinder apparatus. They built a relationship between pressure, specific volume, and temperature for gases. The functional form is known as the ideal gas equation of state. On the pressure, specific volume, temperature surface, the ideal gas equation of state predicts the behavior of gases in the gas region. In this region, temperatures are far above the critical temperature. Pressures are much lower than the critical pressure. And specific volume is much larger than the critical specific volume. The ideal gas equation of state can be applied to gases in this set of conditions, where the compressibility factor is nearly 1. There are several forms of the ideal gas equation of state. Each form is actually the same relationship, with various unit conversions built in. On a molar basis, pressure times volume equals the amount of substance times the universal gas constant times the temperature. R bar is the universal gas constant. It has a value of 8.314 kilojoules per kmol Kelvin, or 1545 feet pounds force per pound mole degree Rankine. This universal gas constant applies to all gases. Using molar specific volume, the equation is cast in the form of pressure times the molar specific volume is equal to the universal gas constant times the temperature. Molar specific volume is similar to specific volume. Specific volume is the volume that a unit mass occupies. Molar specific volume is the volume that a unit amount of substance occupies. Specific volume is 1 over the density, which is equal to volume per mass. The molecular weight, m, capital, is expressed in mass per unit amount of substance. Mass, unit amount of substance, and has units of kilograms per kmol or pounds per pound mole. Note that a pound mole and a kmol are a unit that is not pounds times moles or kilograms times moles. Rearranging the definition of molecular weight, we can compute the amount of substance. The amount of substance is the mass divided by the molecular weight, which gives us an answer in kmol or pound mole. The molar specific volume is the molecular weight times the specific volume. Substituting the definition of specific volume times the volume per mass. We see in this form the molecular weight divided by the mass. This is simply 1 divided by the amount of substance. Finally, the molar specific volume is the volume divided by the amount of substance. A small amount of algebra shows that the two molar forms of the ideal gas equation of state are equivalent. We can also cast the relationship in terms of mass rather than the amount of substance. Starting with the form of PV is the amount of substance times the universal gas constant times temperature, we substitute the amount of substance that we arrived at above. The amount of substance is the mass divided by the molecular weight. This gives us that pressure times volume is equal to the mass divided by the molecular weight times the universal gas constant times the temperature. We define the specific gas constant as the universal gas constant divided by the molecular weight. This has units of kilojoules per kilogram Kelvin or feet pounds force per pound mass degree Rankine. The specific gas constant is different for every substance. Substituting this definition, we arrive at a functional form of the ideal gas equation of state on a mass basis. Pressure times volume is equal to the mass times the specific gas constant times the temperature. We can substitute the specific volume to arrive at a final form of the ideal gas equation of state. Divide each side by the mass. We recognize that volume divided by mass is a reciprocal of density, which is the specific volume. This leads us to the final form of the ideal gas equation of state. Pressure times specific volume is equal to the specific gas constant times temperature. To summarize, there are four useful forms of the ideal gas equation of state. These forms are simply conversions between different definitions of properties, and each can be useful in a different situation. In reality, you only need to know one, and all others can be arrived at as shown above. On a molar basis, we have two forms. Pressure times volume is equal to the amount of substance times the universal gas constant times the temperature. Or pressure times the molar specific volume is equal to the universal gas constant times temperature. On a mass basis, we have two forms as well. Pressure times volume is equal to the mass times the specific gas constant times the temperature. And finally, pressure times the specific volume is equal to the specific gas constant times temperature.